Hello everyone, my name is Sunwoo from KAIST AI. Today, I'm going to introduce our work on a graph neural network, Hello World, making GNNs talk with LLMs. We start with our research background. Graph neural networks, also known as GNNs, are neural networks specifically designed to process graph data. They showed strong performance in various graph tests. The key of GNNs is message passing, which aggregates neighbor information to update the representations of the target node across layers. For example, for the green node, we can average the embeddings of red, orange, and blue nodes and add them to the green node's embedding. However, hidden representations of GNNs are hard to interpret since typical GNN representations are in the vector format. Motivated by this challenge, we aim to cover how we can make GNN hidden representations more interpretable. We now discuss our proposed method, Graph Lingual Network. We improve the interpretability of GNN hidden representations by expressing them as text. Many node attributes are naturally textual, for example, titles and abstracts in citation networks or user profiles in social networks, making textual representations a natural fit. So, we aim to iteratively refine this textual information by using neighbor information as in common graph neural networks. Since text is inherently interpretable, it is adequate for mitigating the lack of interpretability issue of GNN hidden representations. Based on this intuition, we propose Graph Lingual Network, in short GLN. It is a GNN that prompts an LLM to perform message passing. We describe the encoding process of GLN through an example. Let's focus on obtaining the representation of red-colored node A in this example with a two-layer GNN. In standard GNNs, the following iterative process is performed. First, computing each neighbor's representation from its neighbors. Second, updating the target node using these neighbor representations. In GLN, the overall pipeline is similar, but the update step is performed with an LLM. For example, in citation networks, we provide the target node and its neighbors to an LLM, which then refines the target node's description as shown in the slide. In addition, we incorporate two advanced GNN techniques. First is an initial residual connection, which re-injects each node's initial attributes into the LLM to maintain them across layers. Second is graph attention, which led an LLM to focus on neighbors that are relevant to the target node. We now discuss the observations regarding GLN and its downstream task performance. Throughout the observation analysis, we analyze the effect of layer stacking, graph attention, and initial residual connections. First, the node representations of GLN become more general across layers. For the transformer paper, its layer 1 representation covers the application of the transformer in general NLP. Then, at the next layer, the representation extends beyond NLP to include vision and graphs, indicating their representations become more general with depth. Second, with graph attention, representations become target node specific. Given the transformer's translation-based evaluation, attention tends to make the LLM focus on translation task-related neighbors. Without it, the representation covers general NLP. Lastly, the initial residual connection helps preserve a node's initial attributes. Without it, GLN's layer 2 outputs generalize to non-NLP domains. However, with it, they remain focused on multimodal NLP applications. We now evaluate the downstream task performance of GLN in node classification and link prediction against 4 baseline methods. As shown in the table, GLN outperforms the baseline method in most cases, demonstrating its strong zero-shot performance. Let me wrap up the presentation. To textualize GNN hidden representations, we propose GLN, which iteratively refines a node's textual description by prompting an LLM to perform message passing over its neighbors. We provide in-depth analysis regarding its representation and zero-shot downstream task performance. Thank you for listening to my presentation.